Oops. Oh well, we're starting anyway. It's just like Beethoven and miscellaneous weird slurping as the professor drinks his tea. Hello, everybody. Welcome back. Welcome back. Ha! Alright. Am I a little low? I'm a little low. I'm gonna turn myself up just a touch. Just a titch. Just a smidge. Hi! Hello, everybody! Welcome, 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 welcome! So, yes, excellent plumage. So, yeah, hi. Welcome to class. This is class. You're in the right place if class is what you wanted to do. You might be able to tell that I am feeling much more myself than I was yesterday. Fortunately, it seems to have been a 2-day event, I guess, with respect to the sore throat and everything. I'm still not 100%, but, we shall soldier on. I feel like I've got a little bit more of myself today than I had yesterday. But yes. What was I saying? Yeah. Well, yesterday morning I did actually go out and get the COVID test, so we'll know if the professor has plague. Actually, probably already today. I should look online, see if I've got the plague or not. But, yep, anyway. So, I guess I'll start off by asking you guys if you have any questions pertaining to the upcoming test or anything like that. Probably you have questions. Normally there are questions. And hopefully we can get through those quickly so that we can get moving because, as is perpetually the case in this class, we're a bit behind. So, any questions from the class today? Can I get a thumbs up if there are no questions? Can we go over specifically what a for loop does? We're gonna be seeing that relatively shortly, so I'm gonna hold off on that and let the slides do that. But yeah, we do go over for loops in a considerable degree of detail. When is assignment due? Assignment to do. Assignment to do. The assignment to do. Assignment to is due Sunday at midnight. Sunday at midnight. Cool. Good. All right, so let's move along. So, last time we were talking about Unicode characters, or characters in general. It's not really super important at this stage in your Python development curve, if that makes sense. You should just know that strings are data collections. The data that the string contains is characters, and in Python you can use any character. You're not restricted to the ASCII set of characters, which you probably didn't even realize exists until just now. So, yeah, basically any computer character is a valid thing that you can put in a string. And I just demonstrated that by pulling some stuff off of Google Translate at the end of the last class. So, the trick, it relates to the bit width of the underlying representation. Of course, I think this is the first time we've kind of talked about binary in this manner, but essentially the way that characters work in a computer is that you have a set of bits in memory, say 8 bits for ASCII, each additional bit past the... so each bit represents a 1 or a 0. One bit can represent two different values, 1 or 0. 2 bits can represent 4 values. 3 bits can represent 8 values, etc., etc., etc. Each value is mapped to a particular character. That's what ASCII is it's a mapping between values and actual characters. And you can only get so far with 8 bits. That only allows for 256 different distinct characters. So if you want to represent a bunch of characters that are not, sort of the standard ASCII set, you need more bits, which is why we have a thing called UTF-16. UTF-8 is roughly equivalent to 8-bit ASCII. So yeah, all Python 3 files are UTF-8 by default. This means you can use arbitrary Unicode characters in string and text, in string literals directly. So yes, if you wish to, if you want to use Unicode characters, you can also reference them directly by their Unicode code, which is well, it doesn't seem to be working here. Maybe it's capital U? Unicode escape codec can't decode bytes and position. Maybe if I give it a few zeros. 0, 0, 0, 0. 0, 0, 0, 0. Nope. Okay, so essentially, we're going to get into this, but these are hexadecimal numbers. Although there are letters in them, they're actually still numbers. They're just in base 16 rather than in base 10. We're going to get into hexadecimal, so don't worry. So, yes. Anyway, you can also include new lines inside of your strings. /n makes a new line. Oh, I know what it is. I know what the problem is here. I probably have to print it. Nope. Yeah, anyway. No. Stop. There. Print. There we go. So wherever you put /n, it will insert it'll just, it's like pressing enter, putting an enter press into your string, and /t is the same thing, but for tab characters. So there you go. I believe there's also a vertical tab, which is hardly if ever used. But yeah, it's like 3 indents, or 3 enter presses. But yeah, this is mostly useful for formatting data nicely. It's sort of... You won't see as much of this type of thing as you would if you were doing C programming. But yeah. So, this is cool. We're going to talk about string slicing. You need to use U... Okay. Okay, let's try it. Somebody in the chat thinks they know the answer. So, let's try. Oh, I'm not gonna belabor the point. When is the test? It's this Saturday from 9 a.m. on Saturday to 9 a.m. on Sunday. Yes. We will do lots of examples of while loops and for loops, yes, but I imagine you guys are talking... Let me just quickly look through the slides and see if we've got any of these coming up. Okay. Let me see. Let me think. Okay. All right. I will interrupt the slides very briefly for a quick little diatribe about loops, since it's been requested a couple of times in chat. you can consider this review for the test. So, loops. A while loop, you have a Boolean condition, similarly to an if statement, and your while loop will execute whatever's inside of the while loop until that condition turns out false, and then it'll kick you out and continue on. So the traditional sort of formulation for this, let's say we have some variable I is equal to 0 and some variable S is equal to 0. While I is less than 20, S plus equals I plus equals 1. After the execution of that loop, the sum is 190, and I is 20. And that's the sum of all of the digits from 0 to 19, or yeah, 19. Because once I is 20, it won't execute the loop again on the 20th go-round, right? And you guys could verify that on a calculator if you like. A for loop, on the other hand, generally speaking, for loops are designed specifically to operate over data structures. Since strings are data structures, let's operate over a string. Hello world. So for character in string, print character. There you go. So what a for loop does is you have to designate an intermediate variable. In our case, that's character. So character did not exist beforehand, and it now exists while the loop is running. For each iteration of the loop, it picks out the first element in the dataset, the second element in the dataset, the third element in the dataset, the fourth element in the dataset, etc., and it runs the loop once for each element in the dataset, with character each time being updated to be the element in the dataset that you're currently on. That's why if we are just simply printing each character, I'm lecturing! Stupid phone. I'm putting you on silent. You're on notice, phone. It's probably my dentist or something. Anyway, where was I? Yes. So we're gonna do a lot of examples on for loops and while loops, in upcoming topics. For now, it's sufficient for you to be able to know how to use while loops. You don't necessarily need to know how to use for loops. For loops operate in Python very differently than they operate in something like C# or C++. In C++, they're basically a more compact notation for while loops that do a lot of the declarations sort of in this space here. Whereas in Python, a for loop, it's specifically tied to a data structure. If you try to use a for loop over something that isn't a data structure, it'll give you an error. It'll say this is not iterable. Character. There you go. Int object is not iterable. That means that an integer, which is 10, is not a thing that it's not a thing that contains elements. However, you can make it a thing that contains elements reasonably easily just by enclosing it in braces, and then it does count as a collection of items, and that even though it's a collection of items that contains one item, it runs the loop therefore once. So hopefully that's a sort of good crash course. For item in list, yes, or for character in string, for item in whatever. For entry in dictionary is another one that'll come up soon. Yes. Oh, yeah. Sorry. So the plus equals, that's just shorthand for S, as the people in the chat note, that's just s is equal to s plus I. That's just programmer's shorthand. That guy right there. Yes. Ah, thank you. Yes. I went to great lengths to get Porky Means Business from, which is the final boss music for Earthbound, onto my phone as my ringtone. Thank you for appreciating it. Can you use that to change the items in the list? So generally speaking, messing with the list that you're iterating over is a big no-no in Python. So, for example, just a quick example of that. For example, if we have a for I or for k in a tuple 1, 2, 3, 4, 5. Actually, it has to be a list if we want to modify the elements. It's like you don't. Well, I'm using a literal here, so I don't even have a direct reference to the list. So, you know what? I'll just say it for now. If you modify the elements of the list as the list is being processed, the problem that you're going to find is if you are, like, certain modifications you can get away with, just sort of changing values you could probably get away with. But if you're doing things like deleting or adding values, particularly adding values, Python goes through the list. It doesn't, like, keep a copy of the list from the beginning of the loop's execution. It will be picking out these things as the list is going. So, if you add an element to the end of the list, each time you iterate the loop, your loop is an infinite loop. And that's actually pretty amazing, because for loops are kind of designed to be difficult to make an infinite loop with. But, yes. Yeah. Not possible with the data structures that we've done so far, because all of the data structures we've done so far have been immutable, not mutable. But that's okay. Anyway. So, operations on strings. This is string slicing. We are slicing and dicing. So if we have a string... Shut up. Not you. The computer. Hello, world. If we wish to take a... Basically, this is a way... And this works on tuples and lists and strings. Basically, any ordered data set. Dictionaries and sets are not ordered data sets, so this doesn't work on them. But, essentially, you can take sub-arrays or substrings by using some clever stuff. So, if we want the fifth element, we do that. If we want everything up to the fifth element, not including the fifth element, we do colon that. If we want everything between between these guys, you can do that as well. And if you want everything from one point to the end of the list, you can do that as well. The syntax for this is if you include a colon inside of the indexing brackets, the first element is the element at which you start, inclusive, and the second element is the element at which you stop, exclusive. So not including the actual element that itself that is referred to. So if you leave it blank, like if you provide one argument and leave the other argument blank, Python will assume you mean from either from the beginning of the list, in the case of the first element being left out, and or to the end of the list, in the case of the second element being left out. So that's why if I go from the fourth element to the end of the list, I get low world. If I go from 3 to 7, I get low just W. And if I go until the fourth element, but not including the fourth element, I get hell with no O. So there you go. That's essentially list slicing. List slicing is an extremely useful operation. For example, There's actually a third one that we're not talking about there, which is the count by, so that you can include 2 colons and have a count by. So if you want every other character in the string, you do : 2, and because Python is Python, if you do -1, that is Python shorthand for reversing a collection, which is fun. Normally, to reverse a data collection, you have to do a lot more work than that. So there you go. Going through quickly the other operators, just like for tuples, we have the length operator, which works. Length of s is 12. We also have a couple of, these are called methods, which means they're called using dot syntax. It's not important that you understand the difference between them. You just have to use them correctly at this point in time. So if we wanted to count the number of L characters that there are in the string hello world, we do s.countL. And if we wanted to know at what index the first occurrence of the character L is, it says it's at index 2. And you know that because if you call that, you get L. There you go. Now let me see how many people are lost. Yes, so remember that for everything, this is tuples, strings, and lists, all of the ordered data sets. The first element of the data set is always 0. Always 0. So this is called zero indexing. A zero indexing scheme. The only programming language that I've ever encountered which does not use a zero indexing scheme is MATLAB. And MATLAB is it's definitely not a thing that we're going to be using in this class. How does Python determine what the shorthand will look like? I don't know what you mean by shorthand. I mean, if you're asking how is the Python language defined, it's defined in various grammar documents. Could I clarify what s.index does? Sure. S.index finds the first occurrence of a particular character in a string. So if it was O, then then the correct index of that is 4, right? In hello world, it's 0, 1, 2, 3, 4. O. So it gives you the index of it. You can actually also find the indexes of substrings, like not just individual characters, but sequences of characters as well, which is very useful to know. Oh. Right. So this guy. Yeah, it's just taking every other element, right? So it takes the H, skips the E, takes the L, skips the L, takes the O, skips the space, takes the W, etc., etc. That one is : which is, this is blank. So, the first one is blank, so that's from the beginning of the string. The second one is blank, so that's to the end of the string, so we're talking about the entire string. Count by 2, it only takes every second element and smushes it together and makes one thing out of it. Can we use this for a dictionary? No, it has to be an ordered data set. Dictionaries are not ordered data sets. So because you can't index them, well, you technically can index them by integers, but generally speaking, if you're indexing in a dictionary by integers, what are you doing, man? You might as well just be using a list. Although an ordering relation can exist across the indexes of a dictionary, dictionaries themselves are not ordered data sets, which is the technical way of saying that. So, good. Strings are immutable. We can't change individual characters without creating a new string. So basically, if we had string at 2 and we wanted to reassign it to R for some reason, string object does not support item assignment. There you go. However, what you can do is you can do, if you wanted to do something like this, what you would do is you would say the string up to 2 concatenated with R, concatenated with the string from 3 to the back. And that performs the replacement that you wanted to perform. However, it is important to note that this is new. This is an entirely new segment of memory that you have opened up in order to do that. And if you wanted to access the original string, you can still access it. You can even assign this to a new variable, and you still have both copies in memory. You're not modifying the memory itself. You're creating new memory that has the modification. Important distinction. Good. So, some more operations. These operations are also ones that you will have seen on tuples. You can have concatenation, as I just demonstrated. You can have a substring you can have a substring test. So, is double L in string? That is true. Is the character X in string? That is false. There you go, and you've got the negation of that as well. You can repeat it. So if you want to do times 1,000 and 10,000, there you go. There you go. You can just create all kinds of characters. And you also, this is one that sort of pops up quite a lot, actually. It's a thing that you would use quite a lot if you're clever about it, and that's a suffix test. So s dot ends with, does it end with an exclamation mark? For example, what? Oh, it's lowercase w. There you go. However, ends with .ipynb, false. So this is a great way for checking strings to see if they're file extensions, which is a very useful thing that you'll see once we get into file I/O. But at the moment, it's, kind of here nor there. So it's so that's 8. There you go. Cool. So, I'm going to skip print because we already have used print plenty of times. We know what it does. Input, however, is probably something you haven't seen yet. So if you want to gather input from the user, what you do is you say in is equal to input. Input is a method. You put a string inside of the input method, whatever you want the user to be prompted by. So enter a number. Stupid. Or invalid syntax. Oh, that's that's a reserved word. You know what? I'm gonna do this in a file. There we go. Input. We shall say response is equal to input. The results of input, enter a number. Stupid. If response is equal to no, print, well, I didn't really want one anyways. Else, print, ha, I didn't really want a number. There you go. If we execute that, Python 3 topic2.py, Can't open file. Oh, topic2.py. There we go. Enter a number, stupid. Blah, blah, blah. Ha! I didn't really want a number. No. Well, I didn't really want one anyways. There you go. So, that's how you take input from terminal, right? So let me see. Hey, no snooping around my directories. Man, I haven't updated that in a while. Okay, so does AutoGrader have any restrictions on standard libraries? So can you use collections.ordered dictionary? Generally speaking, if it runs on Jupyter Hub, then it's probably fine, as long as you're not doing weird things to import a bunch of libraries. But how do you add spaces between strings? No, you gotta leave the space. You gotta leave the space, man. You gotta leave the space, man. So if you have like S plus space plus T, there you go. That leaves a space. You could do anything. You could do a new line if you wanted. But then you'd have to print it to actually see the new line. There you go. Nope, not subliminal messaging. Nope. Although, if you want to take it as subliminal messaging, yes, cool. So that's how you take input. Generally speaking, this is more informational. It doesn't really work with the AutoGrader having input being taken, so generally speaking, you won't see this very much in assignments. String formatting. Formatting is so this is kind of a thing that's kind of a little bit ephemeral. Generally speaking, you can accomplish this by other means, but so sometimes you're trying to print stuff that isn't a string, and you have to convert it to a string in order to have it print nicely. So, for example, if I wanted to print the value is plus 4.5 decimal place. Error. Must be string, not float. So you've got a couple of options. One of the options is to just perform manual string conversion on the thing itself. However, what if we only wanted to print 3 decimal places? The way that we would go about that is, rather than performing direct string conversion, we use dot format, and we leave a hole in the string into which a floating point number can be placed. And you'll notice that it automatically truncates it to 6 decimal places. For those of you who know what you're talking about, what this is essentially the standard string formatting functions from something like C or C++ put into a different package. These are actually like system libraries that you're interacting with. So this will be reasonably consistent across programming languages, this type of thing. If you do .3, that means leave 3 decimal places. If you're doing this with an int value rather than with a floating point, you use D. D is for integers, and you can also do this with strings. Although why you would use this over string concatenation is sort of best left to the imagination. So, good. So, here are some examples of things that use strings. So if you wish to write a function that returns the frequency in terms of a percentage of a particular character in a string, this also works on tuples, you would just divide s.count by the length of s. And of course, this takes s, the string you're looking for, and t, which is the character you're counting. And then you multiply the whole thing by 100. So if you define function frequency of s and c, I'm going to use c because it's character, return s.count c, and divided by length of s multiplied by 100. So if you wish to have the frequency print the frequency of in this string of, say, the character 8 in some long list of numbers, it's 25%. 1/4 of this string is made up of 8s. So that's, sure. Cool. That's an example. Can I do round? Yes, you can do round. Round exists. Round modifies the underlying value, though, whereas the formatting doesn't. So, if, for example, we had n is equal to this, paste, there we go. And we did that. If we take a look at n, it's still got the old trailing decimal places. If we do round n, that's 5, but it's still unmodified as well. You'd have to do n is equal to round n, and you can even pick how many decimal places to round it to. So there you go. Cool! Man. We've also got an example which pluralizes things. Return w plus es if w dot ends with s, else just with the regular s. So this is an example of doing an if statement all in one line. I generally speaking don't recommend this for beginners. This is essentially the equivalent of C's ternary operator. If you know what a ternary operator is, then you're qualified to use this. Otherwise, just use if statements as regular. In fact, I'm going to just skip this entire thing because, again, there's nothing that this does that you can't do in separate lines. If you already know what a ternary operator is, then you know what this does. But essentially, it just allows you to do an if statement in one line with expressions rather than statements. So I could say x is equal to 1 if y is greater than 10, else 2. If y is equal to 8, then x is 2, right? So expression, if condition else, then another expression. The equivalent in C is condition question mark A colon B semicolon, but that's fine. So, very quickly, we need to talk about Booleans. I'm determined to get this slide set done today. So Booleans, we've been working with Booleans a reasonable amount. So we've got true and false values, right? So true is true, false is false. But what is true and false? That's false. So essentially, think about it. You have to put on your logic brains. You've got a few operators here. You've got and, you've got or. XOR is hardly ever used. It stands for exclusive OR. But essentially, man, I wish I had a blackboard right now. But if you have A and B, what's A and B? What's A or B? This is called a truth table. A XOR B. So if A is true and B is false, A and B will be false. A or B will be true, and AX or B will be true. Maybe I'm not explaining this very well. So essentially, it'll make more sense when I get the whole truth table up. Give me 2 seconds, guys. Don't ask me why this isn't in the slides. It should be. False, true, false, true, true, false, 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 false. So the purpose of these Boolean operators is to take two Booleans, to take two things that evaluate to a Boolean, and then be able to come up with a general... I'm not explaining it very well. These are operators that take two Booleans and produce another one. So you have to think of these trues and falses as being like conditions. So if... Oh, good example. Let's say we wanted to see if a number is between two numbers rather than being less than or greater than exclusively. So, for example, let's say we had a number n, sure, is n less than 2 and is n greater than 7. False. Okay, because that's actually impossible. It's not possible for something to be less than 2 and greater than 7. But what if we flip these? What if... So is n greater than 2 and less than 7? That's true. And if n is put outside of that range, it becomes false, right? The above this case would work with or. So is n less than 2 or is n greater than 7? That's testing to see if the thing is not within a certain range. That is also true. Of course, the other way of doing that is you could just say not all of this, and then that works as well. So these are Boolean operators. They are used for combining multiple conditions in to make more complex conditionals. So yeah. So you've got and. And is true only if the two things going into it are true. Or is true if either of the two things going into it are true. And exclusive or is true only if the two things going into it are different. So, yeah. Boolean. True math speaks. Yes. Cool. Lecture. Yes, good. All right. So, the character for exclusive or is the caret character in Python. So there you go. You also got not, which I already explained. So not true is false, and not false is true. You know, it just gives you the opposite. It's easy enough. This is sort of tied into the idea of propositional logic. So if any of you have done any sort of philosophy, if any of you have studied philosophy, then you will probably have heard the term predicate logic, or propositional logic. Sorry, predicate logic is more mathematical, although it is also, you can also have predicates in in philosophical logic. But anyway, so there's a big difference between mathematical logic and philosophical logic. Generally speaking, the mapping between them is our conditional statements here. These are our predicates in predicate logic according to philosophy. And we are, we're not so much interested in the creation of deductive reasoning or any of those types of things. We are using it primarily as a calculus. We are using logic primarily to calculate things rather than to argue things. So, but yeah, that being said, you can still get a good feeling for how these operators work, because they work the same as they work in propositional logic. So, for example, if the proposition B is I ate ice cream, and C is equal to B, so C is also I ate ice cream, B and C, C is I ate ketchup, then B and C means I ate ice cream and I ate ketchup. Not B and C means I did not eat ice cream and ketchup, although you may have eaten either ketchup or ice cream, right? Not B is I did not eat ice cream. Not C is I did not eat ketchup. Not B or not C, I did not eat ice cream or I did not eat ketchup, so I may have eaten one of them. This is one of De Morgan's laws. So that's all, logic and stuff. So here's a question, and we can actually do this. So if I have the expression not x and not y, or y, what does that evaluate to? True or false, given that x is true and y is false? Please enter your votes into the chat right now. Oh, in the meantime, could I explain this string? The string slicing thing. Sure. So, the difference between :3 is the difference between :3 and 3: is, am I starting from the beginning and going to this stopping point, or am I starting from the stopping, or am I taking this to be a starting point and then taking the end of the string to be the stopping point? That's the question. So there you go. True, 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 true. I clicked off. Oh, sorry. Yes, here you go. So, let's just do this out. So, not x and not y, or y, given that x is true and y is false. Right? Yeah. So, we can begin by just substituting in x and y, right? So, this is false, and this is true. So, not false is true. True and true is true. Not true is false. False or false is false. Not false is true. So the truths have it. There you go. Oh, and just for the sake of clarity and, the fact that this is a live stream, if I've ever flashed anything on the board, in the stream that, you were like, you clicked away too quickly, you can always actually run the stream back a couple of seconds and, hold it there for a second, and then you can even just start playing from there, although it'll desynchronize you from the chat. Yeah. Cool. All right. So, The time is currently 11:19. I don't think we're going to get into topic 3 with 1 minute left in class, less than 1 minute left in class. So I'll take any questions that you might have, and if you would like to ask a question, now would be the time. Yes, cool. Okay. So, why is A1 dropped on Avenue? That's a good question. So, we actually are dropping the lowest assignment grade, despite the fact that it doesn't say that anywhere that we're doing that in the syllabus. So don't worry about that. That just means that your A1 grade hasn't come in yet. We'll put out a little announcement once the grades are up. So, Jamie's question above. Would I8 ketchup not replace what B equals or contains? So yeah, I believe that's just an error in the slides. This B equals should not be there. So imagine that being deleted, please. Could I expand on putting an empty list in to see what happens? Yes, so... Okay. So in the above, let's take an example. Let's take a concrete example. So this guy right here, right? What happens if you request the frequency of a thing that doesn't contain anything? This is actually going to be a really good example. So let's say we put an empty string in there. What happens? You get an error. So a lot of you probably don't know about this, but you can't divide anything by 0 in a computer. In sort of normal math speak, dividing by 0, generally speaking, will result in infinity. Computers are functionally incapable of representing infinity, being finite things, although, you know, they can represent infinity symbolically, but they can't represent an infinite sequence of bits. They're all 1 going off to infinity, right? So, generally speaking, when you ask for a division operation to be performed, with 0 being in the denominator, you trip an error. So, division by 0. Bam. So this is not a safe... So this function is safe for only for strings that are of non-zero length, right? As soon as you put something in there, it's safe to run again. Although this stuff down at the bottom is messing us up now. So, how do you fix this? If length of S is not equal to 0, or if you want to use the operators that we just defined, if not that, there we go, else return 0. There you go. So if this is empty, it returns 0, or something that's considered a safe value, rather than failing out on an error. So generally speaking, that's what we mean by edge cases. Because a string of length a string of length 0 causes a 0 division error, the function as originally written would not pass an edge case test. However, it now will pass an edge case test. Generally speaking, if you believe that you've found an edge case in a test question or an assignment question that does not, like, the behavior that is expected from the function is not specified in the question, that's when you ask your TA on Piazza. So there you go. Hopefully that clarifies things. Oh my gosh. Really? Hopefully you guys can still hear me, though. Okay, there we go. I don't know why it's doing that. How to check grades on JHub. Don't check grades on JHub, check grades on Avenue. Oh, did my mic go again as well? So weird. Much strange. Yeah, okay. Cool. All right. Any other questions? Test, test, test. The A1 grades, as far as I'm aware, have not been uploaded yet. So, just cool your jets. They'll be done soon. Unless, yeah, so I'll see where things are, probably by, I don't know. You know. Again, we will make an announcement when the grades go up. So, yeah. Okay, I think that's everything. I will talk to you guys on Thursday. Take her easy, folks. Don't do anything I wouldn't do. Keep it real. Keep it on the DL. Keep it rolling. Yes, assignment due is due this Sunday. We will have weekly assignments from this point forward, aside from reading week. So there you go. Take her easy, folks.